Ohmic Conductor and Superconductor. By the end of this lesson, you should be able to explain factors that affect resistance, solve problems involving potential difference, current, and resistances, describe superconductors. Three circuits, each consisting of 3 batteries, an ammeter, and a resistor has been set up. Observe the ammeter readings. What can you say about the readings? What can you say about their resistances? What other factors do you think may affect resistance in a circuit? Two circuits are set up as shown. Constantan wires of the same thickness are used in the circuits. In the circuit A, the length of the wire used is 20 centimeters, while in circuit B, the length of the wire used is 60 centimeters. Note the readings of the ammeter and voltmeter in circuit A. Use these values to calculate the resistance of the wire. The ammeter reading is 1.4 ampere and the voltmeter reading is 2 volts. Resistance R is equal to potential difference divided by current. Therefore, the resistance of the Constantan wire in circuit A is 1.43 ohm. Note the readings of the ammeter and voltmeter in circuit B and calculate the resistance of the Constantan wire. The ammeter reading is 0.7 ampere and the voltmeter reading is 3.1 volts. Resistance R is equal to potential difference divided by current. Therefore, the resistance of the Constantan wire in circuit B is 4.43 ohms. Same material and thickness, but have different lengths. What can you say about the resistance and the length of the wire? The resistance of a uniform conductor with constant temperature increases as the length of the conductor increases. Resistance R is directly proportional to length L for a wire of the same material and thickness. This can be represented by the graph shown. Two circuits are set up as shown. The resistance wires used are Constantan wires of the same length. In circuit M, the wire used is SWG30, while in circuit N, the wire used is SWG22. The thickness of a wire is indicated by their standard wire gauge, also known as SWG. A micrometer screw gauge is used to measure the thickness of the wire. The thickness or diameter of wire of SWG30 is 0.8 millimeters, while the diameter of wire of SWG22 is 1.25 millimeters. Hence, wire of SWG22 is thicker than the wire of SWG30. As the SWG number of a wire increases, the diameter of wire decreases. Note the readings of the ammeter and voltmeter in circuit M. Use these values to calculate the resistance of the wire. The ammeter reading is 1.4 ampere and the voltmeter reading is 2 volts. The resistance of the wire of SWG30 in circuit A is 1.43 ohms. Note the readings of the ammeter and voltmeter in circuit N. Use these values to calculate the resistance of the wire. The ammeter reading is 2.2 amperes and the voltmeter reading is 0.6 volt. The resistance of the wire of SWG22 in circuit N is 0.27 ohm. The wires used are of different thicknesses. Which wire has more resistance? Which circuit has more current flowing through it? The thicker wire that is of SWG22 has lower resistance to current compared to the thinner wire that is of SWG30. Hence, more current flows in the circuit N compared to the circuit M. The graph of resistance R against 1 over area of cross-section A is a straight line as shown. For each wire, the area of cross-section A is calculated from the diameter D using the formula area equals pi d squared over 4. Hence, the resistance R is directly proportional to 1 over area of cross-section A for a wire of the same material and at constant temperature. 3 circuits are set up as shown. The resistance wires used are of the same length and thickness. However, constantan wire is used in circuit P, nichrome wire is used in circuit Q, and copper wire is used in circuit R. Note the readings of the ammeter and voltmeter in circuit P. Use these values to calculate the resistance of the wire. The ammeter reading is 1.4 ampere, and the voltmeter reading is 2 volts. Resistance R is equal to potential difference divided by current. The resistance of the constantan wire in circuit P is 1.43 ohms. Note the readings of the ammeter and voltmeter in circuit Q. The ammeter reading is 0.8 ampere, and the voltmeter reading is 2.7 volts. Resistance R is equal to potential difference divided by current. The resistance of the nichrome wire in circuit Q is 3.38 ohms. Note the readings of the ammeter and voltmeter in circuit R. The ammeter reading is 2.3 amperes, and the voltmeter reading is 0.2 volt. Resistance R is equal to potential difference divided by current. The resistance of the copper wire in circuit R is 0.09 ohm. The wires used are of different materials. Which material has the most resistance? Which circuit has the least current flowing through it? The resistance of the nichrome wire is greater than the resistance of the constantan wire, and the resistance of the constantan wire is greater than the resistance of the copper wire. Hence, resistance of a wire depends on the material used. A graph of voltage V against the current I has been plotted. The slope of the graph represents the resistance. What can you say about the slope of the graph when nichrome, constantan, and copper wires were used? What can you say about the resistance of the nichrome, constantan, and copper wires used? When nichrome wire is used, the slope of the graph is greater than when the constantan and copper wires were used. Hence, the resistance of the nichrome wire is greater than the resistance of the constantan and copper wires. A circuit is set up as shown. Click on the switch. Observe the brightness of the light bulb as current increases. The graph of voltage against current will be plotted once the switch is switched on. What can you say about the brightness of the light bulb when the current is increased? Why? As current increases, the temperature of the filament in the bulb also increases. Heat is then converted into light. As more current passes through the filament, more heat is converted into light. Hence, the brightness of the bulb increases. The slope of the VI graph represents resistance. What can you say about the slope of the graph as the current is increased? What can you say about the resistance and the temperature of the filament in the bulb as the current is increased? As the current increases, the slope of the graph also increases. Thus, as the current increases, the resistance of the filament also increases. As the current that passes through the filament is increased, temperature of the filament in the bulb also increases. This then causes the resistance of the filament to increase. Most conducting materials at normal temperature have resistance. Resistance can cause energy loss and heating. Electric trains require materials with very low resistance, so that they can travel at high speed. Do you know of any materials that have zero resistance? Superconductors are materials that have zero resistance. Many alloys and compounds have been found to be superconducting at low temperatures. The temperature at which the resistance falls to zero is called the critical temperature. A superconductor with a critical temperature above 77 Kelvin, such as the boiling point of liquid nitrogen, is referred to as a high-temperature superconductor. Superconducting material with a critical temperature of 150 Kelvin hadn't been found until 2006. Magnetic levitation is an application where superconductors perform extremely well. An electromagnet with coils made of superconducting wires can create a very strong magnetic field. because superconducting wires have zero resistance. Transport vehicles, such as trains, can be made to float on strong superconducting magnets, virtually eliminating friction between the train and its tracks. Not only would conventional electromagnets waste much of the electrical energy as heat, they would have to be physically much larger than superconducting magnets. The speed of the maglev train can go up to 531 kilometers per hour. How does the number of wires connected in parallel affect the resistance in the circuit? Carry out the following instructions. Click on the number of wires needed in the circuit. Click the switch to start. Click on the rheostat so that the ammeter reads 0.5 amperes. Click Record the readings for current, voltage, and resistance. Click Graph to see the slope after all 5 wires are connected in parallel. From the graph, state the relationship between resistance and the number of wires connected in parallel. What can you tell about the total area of cross-section of wires when the number of wires used increases? When the number of wires increases, the total area of cross-section of wires increases too. The larger the number of wires used, the smaller the resistance.